cost ratio for like diets, recommended diets. What is different from the other or the existing ration formulation tool here is we have an algorithm that also tells us the carbon footprint of the diets recommended from the ration formulation tool. So we have three different objectives, right? So we have increasing the productivity. That diet comes from the ration formulation has a least cost. So we're trying to improve the productivity by decreasing the cost of the production, at the same time also decreasing the emission, the methane emission intensity. Um, so we have different organization and implementing countries. Um, we have in the West and Central Africa, including Cameroon, Burkina Faso, Nigeria, Chad, Gabon, Togo, um, recently in Morocco and also East Africa, Ethiopia. Um, we have most of the countries in South Asia, Indonesia, Thailand, Philippines, and Vietnam. We are from South Asia's Nepal and India. Nepal, India is coordinated by Cornell University. We have CSIRO from Australia, where they try to see the relationship between the fecal sample, using the fecal sample to estimate the feed intake and methane yield. So through this project, we will have an in vivo trial. I will come back to that later. We will have in vivo trial to validate the ration formulation tool. But the fecal sample coming from the in vivo trial will be used to calibrate a model that will allow us to predict the feed intake and the methane yield. So at some point, if we are succeed to get a good correlation between the fecal sample and the feed intake and methane yield, so we don't necessarily to have a tool, a device like Griffin immersion or respiratory chamber to estimate methane emission from the livestock sector. So CSIRO is working with all these countries to develop a model, an model to estimate feed intake and methane yield from the fecal sample. We have ILRI in Michigan University. They're using the finest equipment, the NRI machine in RGB camera. So what I mean is, Michigan University is leading one of the components under this project, where once we collect the feed sample, representing samples from different regions, different areas, we have a specialized camera, RGB camera, that's taking images of those samples as it is. If it's orange, fresh, we can take as it is. If it's dry or straw, we can still take an image of that sample. And Michigan University tried to look into the relationship between this spectra of this image of this feed sample with the weight chemistry data. So if they found out that there is a strong correlation between this spectra of this image with the weight chemistry, like protein content, energy content, and dry matter content of the feed sample. So at some point, we don't necessarily do a weight chemistry, right? We can actually take a picture of any feed material and understand the nutritional composition of the feed material. Implying that, when we have a ration formulation to at the end of this project, we can relate by this technology into the ration formulation. So we take the image of the feed material and add the chemical composition of that material into the ration formulation. So this is one of our components. The other component that we have is, we know that analyzing the chemical composition of feed material is laborious expensive, right? Time consuming. In addition to that, what Michigan University doing is it's also doing the NR spectral analysis, where they scan every sample that we collect in every country, right? Try to develop a calibration model for NR. Everybody knows, I'm sure that as an animal nutrition, everybody knows that NR tool or NR machine, they need really a strong uh, calibration model. And usually those models are developed under limited feed diversity.